Hi, I'm Mr. Huber, and in this video I would like to introduce the factored form of a quadratic function. Before we do that, we're going to look at what we know so far. So we're going to do a quick recap. Ax minus u squared plus b vertex form. It's called that because we can read the vertex of the function right away. We know the vertex is uv. A tells you whether the graph is happy or sad, a vertical stretch or a vertical shrink. Now, the second form we know quite well now is the general form, ax squared plus bx plus c. Well, still, you do have the same a here. So it tells you happy, sad, a vertical stretch or vertical shrink. And you can read the y-intercept right of the function. Y-intercept would be 0, c now. Well, I said this is the so-called general form. And now the new form we're going to look at is the so-called factored form. Well, it looks like this: x minus z1, x minus z2 with an a. Same thing with the a. A tells you happy or sad, vertical stretch or vertical shrink. And z1 and z2 are the zeros. Of the function. And this is the so-called factored form. Factored form. So let me give you a first example. First example could be f of x is equal to x plus 3 and x minus 5. So this form is quite practical because you can know the zeros right away. But first, let me show you that this is in fact a quadratic function. Look, you could expand it. Well, x times x here, that's x squared. X times minus 5, that's minus 5x here. Then 3 times x, that's plus 3x. And 3 times minus 5, that's minus 15. Well, let's simplify this a bit, and we'll get x squared minus 2x minus 15. So this is clearly a quadratic function. Now, this tells you the y-intercept. Okay, that would be 0 minus 15. It's a quadratic function in its general form. You could have found that out by plugging in 0, because that's the value at 0, the y value at 0. If you plug in 0, you get 3 times minus 5, that would be minus 15. So you could work it out quite easily. So why is this such a good thing? Because when you set this one equal to 0, you get x plus 3, x minus 5 is equal to 0. And you know, whenever a product is equal to 0, well, a product like this, a times b is equal to 0, then either a is 0, because 0 times b is 0, or b is 0, a times 0 is 0, or both are 0. 0 times 0 is 0. So in this case, you can use that piece of knowledge or piece of information. X plus 3 is equal to 0. Either this first factor is equal to 0 or the second one. So let's see, x would be minus 3. Or x minus 5 could be equal to 0. That would mean x has to be 5. Now let's think this through. When you plug in minus 3, you get 0 times minus 8. That would be 0. So this is correct. If you plug in 5, you get 8 times 0, and that would be 0. They can't be 0 at the same time, both at the same time, because in order to make this 0, you have to plug in minus 3. In order to make this factor 0, you have to plug in 5. That's quite clear, I think. So now the interesting question will be, how do we get from this to this later on? But first, let's carry on with this function here. Because look, when you know that your function has two zeros, here we go. It has 1 0 at -3, let's say that's about here, and 5, that would be here, -3 and 5. Then you know that your y-intercept is at -15. So that could be here, -15. So when you draw your graph, it will probably look somewhat like this. And now you see something, because as this function is symmetric, and it's always symmetric with respect to the vertical line through the vertex. So let's have a broken line here. That means this distance is equal to this distance. That means this is right in the middle. And that's very useful, because now you could say -3 plus 5 divided by 2. That's 2 divided by 2. That's 1. So at 1, you will have your vertex. So you know that your vertex is 1 something, okay? We don't know the y value just yet, but that's easy to work out, because you can plug in 1 into your function and it will give you the corresponding y value. So if you plug in 1, that's 1 plus 3, 1 minus 5, so that's 4 times -4, that's -16. So this is going to be 16, -16. And that makes quite a lot of sense when you look at my graph. Your vertex is at 1 minus 16. So all you have to do, once you know the zeros, you can take the arithmetic mean, Durchschnitt, das arithmetische Mittel, the arithmetic mean of these two numbers. You just add them up and you divide them by 2, like you would do it with your average mark. So let's say you have a 5 in the first test and a 6 in the second test. Well, then you add them up and you divide them by 2 and you get a 5.5. Well, here, same thing. You have a 0 at -3 and you have a 0 at 5. You add them up, you divide them by 2, and you know where your vertex is. In fact, you know the x value of the vertex, not the y value. So from these two pieces of information, the zeros, we were able to work out the vertex, because it's just the value in between the zeros, and then you work out the corresponding y value. What else? The y-intercept is easy to calculate, because you just plug in 0 into this function. 3 times -5, that would be -15, or you work out the general form and you read it off that, okay? So in the next video, we're going to look at how to get from here to here. How can we do that? So I hope it wasn't too difficult. See you on the next one.